All right, so now that we've discussed this iterative implementation, what we're going to do is now implement binary search recursively, okay? So let's just take note that this keeps going while the top index is greater than or equal to the bottom. So if you kind of take a look down here, what we're going to do here is we had to add two parameters because when you call on a method recursively, right, it actually creates another stack frame in the call stack. And so the local variables, such as up here, bottom, mid, index, those are not carried along when you call on the method. It creates another stack frame, and they don't have access to the local parameters from the previous frame. So you have to include that information when you make that recursive call. Okay, so that's why we've got to include as part of the parameters, the bottom and the top index. So in terms of the base cases, there's actually going to be two base cases here, right? And we can take this top base case from the while loop condition. So we know that if we call on, we can assume that when we call on binary search recur, okay, and we give the array and the item we're looking for, we'll assume that the first time you call it, the bottom index will be 0, and the top will be nums dot length minus 1. Okay, nums dot length minus 1, the index of the last element in the array. So when do we know if the target is just not in the array? Well, if we meet this condition here, okay, if top greater than or equal to bottom is no longer true, in other words, if top is less than bottom, then at that point, you know you're done searching through the array. So let's go ahead and include that here. If top is less than bottom, at that point, you know it's not there, so you're going to return -1, okay? And then because this is going to be returned, we can just include another statement here. So we want to just check if you are given an array, okay, and let's just make up an array right here. And let's just say that we're lucky, right? And we have, let's say we're looking for 6, and it happens to be in the middle. So first, you check if your bottom and top just kind of crisscross, it's not there. But if you compare, like first we have to know what the midpoint is, so let's calculate it. So mid is going to be, again, to ensure there's no overflow, you can say bottom plus top minus bottom divided by 2, okay? So in this case, it would be 3, okay? So here, if this is M and this is B and this is T, if we're lucky and if the item we're looking for is equal to, in this case, the name of the array is nums at mid, well, then we're done, right? And we can return the index, which in this case is mid. And that would be awesome. We would be done, right? But if that's not true, then we're going to have to make the recursive calls. So these are the recursive calls down here. Need a little more space. Okay. So now what we're going to do is so we have the case where it's not there anymore, right? It's just not in the array, or it's the midpoint. So what we can do now is say, well, what about if our value at the midpoint is less than the target number? So let's compare that. If we have nums, okay, mid, okay, so that would mean in this case, let's say instead of we're looking for 6, say we're looking for 7, okay? So if this number 6 is less than the target number, right? So if it's less than the target number, which in this case we call item, okay? Then we know that we're going to actually make the recursive call at that point. So we're going to call on binary search. Okay, and the parameters are going to be the same array. It's going to be the item that we're looking for. But what are we going to reassign here? So let's say that our item here that we're looking for is 7. We're looking for 7, right? We're looking for this number right here, okay? And this value is 6. So that means the number we're looking for has to be somewhere over here, right? So we're going to reassign bottom to mid plus 1. So now my bottom is going to be mid plus 1. And my top will be the same, okay? And therefore, if it's, that was if I was looking for 7, right? And then the value of the midpoint was too low. But if it was the other way around, then I would do and reassign the top. And then I would eliminate the top half and reassign this to mid minus 1, right? The top to mid minus 1. So we'll return binary search nums item. The bottom would remain the same, and then the top would be mid minus 1. Okay, so again, because this is going to be on a different stack call in our a stack frame in our call stack, okay, you have to carry that information of what we're going to consider the bottom and the top, the new bottom and top indices. You have to carry that as actual parameters. All right, I hope that was helpful, and I will see you in class. Bye.